Black holes are, without a doubt, the most mysterious and feared objects in the universe. They are not simple celestial bodies, but regions where gravity reaches such an extreme level that nothing can escape its pull, not even light itself. They mark the boundary between what is known and what is impossible, the place where the laws of physics cease to behave as we understand them. It all begins with a giant star, a colossal sphere of gas that burns for millions of years. But when it exhausts its nuclear fuel, its own weight crushes it in upon itself. The collapse is so violent that the core is compressed into a point of infinite density, a singularity. Around it forms the event horizon, an invisible frontier that marks the point of no return. When a planet, a star, or even light itself crosses that threshold, it disappears forever. From the outside, it seems to be absorbed, sucked in by an unstoppable force, but in reality, what happens is far more complex. A black hole is not a cosmic vacuum cleaner indiscriminately devouring matter, but a distortion of space and time so intense that anything that approaches becomes trapped within its curvature. The reason black holes can swallow entire worlds lies in their extreme gravity. The more mass they contain, the more they deform the fabric of the universe around them. Imagine a heavy ball placed on a stretched rubber sheet. The heavier the ball, the deeper it sinks. In the case of a black hole, the fabric doesn't just sink, it tears. That rupture in space-time is so deep that no force in the universe can oppose it. When a planet ventures too close, the difference in gravity between its near and far sides rips it apart. Astronomers call this process spaghettification. Matter is stretched and disintegrated until it becomes a torrent of energy spiraling into the abyss before vanishing into darkness. The fascinating part is that, although from the outside it appears to be an absolute end, part of that matter generates powerful energy jets capable of lighting up entire galaxies. At the heart of many galaxies, including our own, lurk supermassive black holes, with masses equivalent to millions or even billions of suns. They are the silent engines of the cosmos, shaping the structure of the universe around them. Ironically, without them, galaxies might not exist as we know them today. What's most unsettling is that black holes also warp time itself. The closer you get, the slower time passes for you compared to the rest of the universe. If someone were to fall into one, the journey would feel instantaneous from their perspective, but to an outside observer, that person would appear frozen in time, trapped forever on the edge of eternity. And yet, the greatest mystery remains unsolved. What lies inside a black hole? Does matter truly vanish, or does it transform into something beyond human understanding? Some scientists believe it could be a doorway to another universe, or even the birthplace of a new Big Bang. Others argue that information is never truly destroyed, but rather encoded on the edge of the event horizon, waiting to be released one day. The truth is that black holes do more than challenge our science. They challenge our imagination. They are the purest reminder of how small we are in the face of the infinite cosmos, and how many secrets the universe still guards, hidden deep within its eternal darkness. As astronomers have refined their instruments, black holes have ceased to be mere theories, and have become real protagonists of the cosmos. What was once invisible now reveals itself through its effects. Spiraling lights, stars that seem to dance around a dark point, and radiation emitted by matter being devoured. Yet, even with our most advanced telescopes and radio arrays, what happens inside them remains an absolute mystery. One of the most unsettling discoveries is that black holes are not only destroyers, but also creators of energy. When matter is dragged toward the event horizon, it spins at speeds close to that of light. That friction, that impossible acceleration generates streams of energy known as relativistic jets, which can extend for thousands of light years. These beams of radiation ionize the interstellar gas, and, in fact, help create new stars. Thus, what they destroy on one end can give birth to life on the other. This leads us to a fascinating paradox. Black holes might be the universe's recycling mechanism. Matter, energy, and information vanish into them, yet part of it returns transformed. In a sense, they are the lungs of the cosmos, inhaling the old and exhaling the new, in an eternal cycle that sustains galactic life. Scientists have also discovered that black holes are not static. They can move, merge, and grow. When two black holes collide, the entire universe trembles literally. That collision generates gravitational waves, ripples in the fabric of space-time that travel across the cosmos, and that, thanks to detectors like LIGO and Virgo, we have already been able to hear. Each of those waves is like a cosmic note, a melody from the ancient universe, telling us about its violence and its beauty. But there's something else that has defied every expectation. Black holes can evaporate. According to Stephen Hawking's theory, even the darkest void emits a faint radiation known as Hawking radiation. This phenomenon implies that, over billions of years, black holes could lose mass and eventually disappear. If true, it means that nothing in the universe is eternal, not even the devourers of worlds themselves. And so arises the deepest question of all. What happens to the information that falls into a black hole? Classical physics says it is destroyed forever, but quantum mechanics insists that information can never truly vanish. This dilemma, known as the information paradox, has kept scientists debating for decades. Some propose that information remains encoded at the edge of the black hole, in a thin layer of energy that stores every atom it consumes. Others, bolder still, suggest that what goes in does not vanish, but instead emerges somewhere else in the universe. There are theories that go even further. Some physicists believe black holes could be bridges between dimensions, gateways connecting parallel realities, or even entire universes. If that were true, every black hole could be a portal to another cosmos. A crack between worlds where the laws of physics themselves are rewritten. Imagine that what we see today as destruction is, in reality, a form of transit, that every star collapsing into darkness is simultaneously being born in another realm. In that case, black holes would not be the end, but the beginning of something far greater. Astronomers suspect that the universe is teeming with them. Some are as small as a mountain. Others, like the one at the center of our galaxy, are so massive they could contain millions of suns. And yet, they all share one thing in common: their power to distort the perception of time, matter, and reality itself. With every new observation, the mystery deepens. Each image captured by telescopes like the Event Horizon Telescope, which photographed for the first time the shadow of a black hole, reminds us that we are still standing at the threshold of understanding. What we see is only the surface of something much deeper, something that seems to be watching us back, from beyond space and time. Perhaps black holes are more than physical phenomena. Perhaps they are the universal balance between creation and destruction, between order and chaos, between beginning and end. Because within their dark hearts, where everything seems to end, may lie the oldest secret of the cosmos, the very origin of existence itself. If black holes represent the limits of human knowledge, wormholes are the promise of the impossible. Imagine the universe as a sheet of paper. If you fold that sheet, two distant points can touch. A wormhole would be exactly that, a tunnel through space-time, connecting regions separated by thousands or even millions of light years, or perhaps even different dimensions. Their existence has not yet been proven, but Einstein's equations of relativity not only allow for them, they predict them. Wormholes could be the hidden reverse side of black holes, the exits of that unimaginable flow of energy and matter that seems to vanish into darkness. While black holes absorb, white holes expel. They are, in theory, their perfect reflection, places where matter cannot enter, only emerge. If both were connected, they would form a cosmic bridge, a natural tunnel through the fabric of the universe. And if that tunnel were stable, something that, today, seems almost physically impossible, it could allow travel through space, through time, or even between parallel universes. This idea has fascinated scientists and dreamers alike. Carl Sagan explored it in his novel Contact, and modern physicists like Kip Thorne developed the mathematics behind it. In theory, a wormhole could allow you to traverse in seconds distances that light would take millennia to cross. It would be the ultimate route of interstellar exploration, the shortcut to the unknown. But there's a price. A wormhole cannot remain open with the matter we know. The laws of physics dictate that it would collapse instantly. To stabilize it, something beyond our understanding would be required: negative energy, an exotic substance that repels rather than attracts. If humanity ever discovers how to create or control that form of energy, we could hold in our hands the key to crossing the universe itself. Wormholes also open the door to an even more unsettling idea: mirror universes. If what enters a black hole is not destroyed, but instead emerges somewhere else, could it emerge into another universe with its own physical laws? Some scientists believe that our Big Bang may have been exactly that: the expulsion of matter from within another collapsing universe.